Last week, NASA's Europa Clipper mission launched with the ambitious goal of exploring whether Jupiter's moon, Europa, could harbor life. The spacecraft will travel approximately 2.9 billion kilometers over the next 5.5 years, reaching Jupiter, they say, in April 2030. And not too long ago, also, SpaceX, with its fifth Starship vehicle, achieving that groundbreaking feat of, did you watch the footage of that, where they had that arm out and they kind of caught the heavy booster upon its return to the launch site? That was pretty amazing. So these missions, I think, show great advancement in space exploration. Let's find out more. We have invited to the airwaves Professor Joshua Colwell, Pegasus Professor of Physics and Associate Dean of the College of Sciences at the University of Central Florida. Hi, Professor. Thanks for joining us.
안녕하세요. Hi, how are you?
Oh, my goodness. 안녕하세요 to you as well. I know you're in Florida. I do want to ask, so is everything okay with you, your campus, your family? Milton, were you not affected?
Thanks very much. Yeah, so the university was closed for most of the week because of Hurricane Milton, but we fared fine. Thank you.
Ah, yes, that's good to hear. So first up, this primary goal of the Europa Clipper mission, what exactly is the primary goal? And why Europa? If you can explain it to us in layman's terms, please.
Sure. So the basic goal of this mission is to understand whether or not Europa is a habitable world. And the reason that we're asking that question about this moon in particular is that we know from previous observations that there is a subsurface liquid water ocean beneath an icy shell at Europa, that water erupts onto the surface, and there have been observations of geysers or plumes coming out from the interior of that world. And so where there's liquid water and a source of energy, which there is for this moon as it is sort of stretched and pulled by Jupiter's gravity that provides some heat in the interior. If there are also the necessary ingredients for life, it might be not only a habitable world, but a world where there is life at this time.
Oh, that's pretty amazing, though, to think about that. Not just is it habitable, meaning can things live there, but do scientists really think that there is life, that potentially life might exist on Europa?
It's certainly possible, and it's a very serious question to pose. But that's why we're going there, to find out how likely it is. Europa Clipper will be studying the surface of the moon, the environment that it's orbiting in. It has instruments that will actually be able to measure the composition of material that is knocked off the moon. If there are plumes, it'll fly through those plumes and sort of sniff those plumes and figure out what they're made of. And determine whether or not they're the basic ingredients for life there. We won't be able, I'm afraid, to answer definitively whether or not there's life in that subsurface ocean, because we're not actually going to go beneath the surface. We're going to have to rely on what Europa gives us by its natural geological processes of putting material from that subsurface ocean onto the surface, and then that amazing set of scientific instruments that the mission has to analyze those materials and see what's there.
I see. So speaking of those scientific instruments, if you can just tell us a gist of what we're looking at.
Sure. Yeah, so it's got 9 main instruments on the spacecraft, and this is a very large spacecraft, by the way. It's the largest interplanetary craft that we've ever launched. And those instruments are sort of a set of cameras that look at different wavelengths of light or different colors. So there will be some amazing pictures that we'll be seeing, as you mentioned, when we get there in 2030. And some of those cameras are looking at light that we can't see with our eyes, but that tell us things about the temperature and about the composition. And we'll be looking in particular for organic molecules and things like that, or warmer regions, which suggest that maybe the water is closer to the surface. And then there's another set of instruments that will be measuring the environment that Europa is in. What are the charged particles in Jupiter's magnetosphere and how they're affecting the surface? And then again, any material that's knocked off the moon, hopefully we'll be able to fly through and actually get a taste of what the surface is without actually having to land on it.
Wow. It boggles the mind, though, the fact that we are this advanced in technology, where I know it's going to take 5.5 years to get there, but the fact that we'll know, hopefully within our lifetime, more about Europa.
Absolutely.
Amazing. So
Yeah, no, it's a real it's a detective project in some sense. There's all these different clues, and you pick up all sorts of different measurements in different ways and piece it together, and then you're able to assemble a picture that tells you more about what's going on, what that world is like.
yes.
Very exciting mission.
So in your opinion, Professor Colwell, what do you think is kind of possibly the most exciting part of this mission? Because you gave us the logistics and spoke about some of the instruments, but I'm sure for you personally, you're thinking, I want to know this. I hope they come back with some sort of finding on this.
Well, we haven't gotten, it's just part of it's just going to be the amazing views that we're going to see of this world. It is a young surface. We think about the moon. We can go outside and we can take a look at the moon with the naked eye or through binoculars and see a bunch of craters. And it's looked that way more or less unchanged for billions of years. But for Europa, it's constantly resurfacing. And so there's going to be all sorts of interesting landforms that we'll have never seen up close. And then the spacecraft will be flying within, I believe, 25 kilometers of the surface of Europa. Very, very close, if you can imagine navigating a spaceship from that great distance and flying that close to your target at those great speeds. And so what I'm really hoping is that we will see eruptions or geysers or plumes coming from that subsurface ocean that will be able to fly through that material. There's a similar situation with the moon of Saturn that the Cassini spacecraft studied. And I'm really hopeful that we'll see that same kind of activity at Europa and that there will be some surprises in there. We have our speculations about what there will be. But the most exciting thing about science is we have our set of questions and we think we're going to figure out the answers. But then when we're working on answering those questions, new ones pop up, things that we hadn't considered before. So it's the unexpected that I'm most excited to see come back from this mission.
Indeed. And we have a question from one of our listeners, Professor, and it is pertaining to what you just mentioned about, potentially geysers and whatnot. So Leslie asks, if there are geysers bringing water to the surface, will they be able to obtain water samples to see if there is microbial life in the water? Are they going to try, or is this just, yes.
Right. Yeah. We won't be going down to the surface on this mission. So everything will just be a flyby at very high speeds. And if there are those geysers that are putting material out into space, it is possible that the spacecraft can fly through that material and it'll sample it, but it won't be like droplets of water. It'll be individual molecules or ice grains or grains of other molecules that are mixed together with ice. So think of tiny ice crystals, and the instruments on Europa will break those apart and analyze their composition. But we won't be seeing, even if a microbe did come out, we wouldn't be able to identify it as such with the instruments on the Europa Clipper.
I see. Thanks for clarifying that one. And if we can take a look, switch gears just a little bit, because at the beginning in the intro, I did talk about, the Europa Clipper, but also SpaceX, because we all saw that footage. Pretty amazing. I was like, is this real? Is this for real? Because,
Right.
And it was
very
so
science
amazing.
Fiction.
Yes. The rocket, it blasted off, and then it came back, it was doing a reverse, and then, the arms, and, they're calling that the Megazilla robot arm, and Koreans have dubbed it chopstick arms. Because people are so interested, fascinated by what happened. Can you explain this recent flight test?
Yeah, so this is as you mentioned, a flight test, integrated flight test 5 of SpaceX's Super Heavy Starship combo. And there's kind of two different aspects of that we're interested in. One is that NASA is relying on that architecture and the Starship, the upper stage of that rocket that SpaceX has developed, to return astronauts to the surface of the moon. So that is the planned landing vehicle for NASA's Artemis project, which is the follow-on to Apollo. So we need to see that working, and we need to see a lot more successful flight tests. There are many more steps to go before we see that landing on the moon. But also, as you saw, bringing that giant booster,
Yes.
70 meters tall, back to the launch pad, catching it with the chopstick arms, and then being able to basically refuel it and launch it again once they get that all worked out. In principle, that makes launching very large things, including groups of people into space, much more affordable and something that can be done more frequently. So it's definitely very exciting. It was an amazing feat of engineering and technology to see that, and it's going to be very interesting to see the subsequent flight tests that we have for that. And hopefully, the idea is making space more accessible.
Yes, and speaking of that accessibility, I mean, the use of these reusable rockets, for example, like with SpaceX's projects, the long-term plans for space exploration. I mean, does this all fit into, of course, the budgeting? Because we all know NASA, lots of cuts in terms of budgets, right? And so we have these private firms now. I mean, they go hand in hand, do they not?
Absolutely. And it stands to reason that if you don't have to build a new rocket every time you launch something into space,
yes,
that's got to save money. Of course, it's still a very challenging activity, and it's very risky. Very high energies are involved. So if you're putting people on board, it's a very risky endeavor. So it's still, we're not at the point yet where going into orbit around the Earth is going to be like taking a flight from Korea to the United States, for example. So there's a long way to go before we get to that level, just because of the physics involved. It just requires much more energy. But it is bringing costs down. We're seeing far more launches now than we were 10, 15 years ago, even during the space shuttle era, which was a reusable launch vehicle.
Yes.
There have been such great strides made in reusability of launch vehicles that it is transforming the way we utilize and take advantage of space and the final frontier.
Yes, indeed. And for our final wrap-up question today, Professor, how does all of this, aside from the aesthetics and like us being wowed by all these clips, how does this benefit us in the long term as just average citizens here on planet Earth?
There are a tremendous number of benefits that we're getting from the space environment and space economy already that we sort of take for granted. GPS, the fact that we can know exactly where to go anywhere, that relies on satellites,
right?
A network of satellites. SpaceX and other companies are developing Wi-Fi satellite networks that are bringing Wi-Fi accessibility to people that would otherwise not be able to get it, including in areas you mentioned, the hurricane here, that can wipe systems out. If you've got a satellite view and a satellite receiver, then you can have access to that sort of thing. There are also discussions about mining materials, getting materials that are rare on the Earth and retrieving them from asteroids. And, in the longer term, we think about things like space tourism. I said we're not yet at the point of going from the United States to Korea in an airplane, the same as going from here to the moon or going to a space station. But that is becoming something that is more imaginable, that people could go into space. And I think, just as a sort of final note, I think one of the most important things that people going into space has as a benefit for all of us is what's called the overview effect, which is realizing how thin and fragile our ecosystem is, how thin the atmosphere is, how vulnerable it is. And there's nothing like going up above. It's only a few tens of kilometers to get above the atmosphere, and then discovering that there are no political boundaries down there, and we have a very fragile environment. So I think space provides us that kind of view that we don't otherwise get.
Right. Thank you so much for not just all the technical aspects, but providing us like this insight, this overview effect, something that we can really think about today as we kick off our day. But thank you so much for your expertise and for this interview, Professor.
감사합니다.
감사합니다.